Good morning. We are in the Unit 4, distributions of random variables. And then in this video, I'm going to talk about continuous distributions, in particular the case of the uniform distribution. Okay, so I'm going to present a problem to understand this kind of distribution. Let's assume that we have a train that leaves from a station every 20 minutes. And then let's assume that we have one traveler that arrives at the station to take the train. So let's assume that this person does not know the schedule of the trains. So he just arrives at random without any knowledge about the schedule. Okay, so then we define the random variable as waiting time, the time since the traveler arrives until the train departs. Okay, so what would be the minimum and the maximum value of x? I think that it's quite obvious that the minimum value is 0, so the person just arrives and he catches the train and the time of waiting is 0, and the maximum is 20. Imagine that the person arrives and just at that time the train has just departed and the person has to wait for the next train. So the maximum time is 20 minutes. Okay. Then in the next question would be, try to draw a histogram for the values of the x. Okay. So we can think about different kind of histograms, something like this. I'm going to present different. Okay. Remember that always the minimum has to be 0 and the maximum has to be 20. And this histogram, lower values are more frequent. Okay, in the second option, intermediate values are more frequent. In this third option, lower values or values close to 20 are the most frequent. And here, in this fourth possibility, all range of values has the same probability. Okay. Well, so if we think for a while, I think that it's more or less, we can arrive at the conclusion that this is the case, okay, because the person has no idea about this train schedule. It's like choosing a random variable in the scale of time, okay? So it's like if I choose a value of time, all the intervals have the same probability, okay? So this would be the expected shape of the histogram. Okay, good. Then what would be the average and the median? Well, if the histogram is symmetric, the average and the median is the axis of symmetry. In this case, okay, this is a symmetric distribution, so both are the same. The average is equal to the median, and this is equal to 10, which is the axis of symmetry. Okay, and then calculate the density function. Remember that I explained in a previous video that the density function describes the shape of the histogram. So if the histogram is like flat, the density function will have that kind of shape, okay? This kind of shape. And then remember that the area below any kind of density function has to be 1. So we have to think about this value, k, okay? So based on this condition that the area has to be 1, this is the area of the rectangle, and so k has to be 1 divided by 20. Okay, so that the base multiplied by that height would be 1. So this is the density function. Less than 0 is null, higher than 20 is also null, and between 0 and 20 it's a constant. Good. Okay, the density function is constant and it's called a uniform distribution. We usually represent like that. X follows a uniform distribution and it has two parameters that we call A and B. A is the minimum value and B is the maximum value. Good. So we say that the density function of a uniform distribution is 1 divided by B minus A in this range of values and 0 outside this range. Good. Then imagine that the next question is to calculate the probability that this random variable is less than 7. Okay, so we can make this calculation graphically. So from 0 to 7, we have to compute this area in blue. So this is the area of a rectangle. So we multiply the base by the height, and the probability would be 7 divided by 20. Good. So the average, remember that it's the axis of symmetry, which is the minimum plus the maximum divided by 2. And the variance is not so obvious. The variance is computed by applying mathematical expectation. And in the video about that, I had a problem which was very similar to this. So you can this video, and so in that video there I justify why the variance is this. It's b minus a squared divided by 12. Good. What is the distribution function? This is the equation. The probability that the random variable is less or equal than x, this is the value. So it's x minus the minimum divided by the maximum minus the minimum. And then what is this calculation? Well, this is a conditional probability. This is a type of problems that quite often we put in exams. And then knowing that x is higher than 5, what is the probability that x is less than 15? Well, we have to apply the formula for the conditional probability, which is the probability of the intersection of both events divided by the probability of the event that goes after the slash. In this case, after the slash, we can have that x is higher than 5. This is what we have in the denominator. And then we have to think about the numerator. So what is the range of values which are less than 15 and at the same time bigger than 5? It's the same as the range of values between 5 and 15. And the denominator bigger than 5 is the same as being between 5 and 20. Well, so this calculation is easily obtained by thinking in the area of a rectangle. Between 5 and 15, it's a rectangle. The base is that difference. The height is 1 divided by 20. And in the denominator, between 5 and 20, it's like the area of the rectangle. The base is between 5 and 20, the base is 15, and the height is 1 divided by 20. So we make this calculation, and the final solution is 2/3. Good. So now let's imagine that we have one random variable which is uniform between 0 and 20. We have another variable which has the same type of distribution, and then the third variable with the same type of distribution. And then let's assume that the three variables are independent, which means that there is no correlation between them. Well, what happens if we sum both of them? If we sum x1 plus x2, okay, so I made the simulation, and this is the shape of the histogram. So this shape is like a triangle, exactly like a triangle, okay? So it's interesting that the same of two uniform distributions with the same distribution that are independent follows this kind of triangular distribution, in this case between 0 and 40. What happens if we sum three uniform distributions? Well, this is the shape. I obtained this by using simulation data, and then it's not a triangle. It looks more or less like a bell, and actually it resembles the Gaussian bell, okay, like the normal model. Okay, and this is interesting because there's a theorem that I will explain in a future video, that the sum of uniform distributions follows a normal distribution. And sometimes we ask, how many uniform we have to sum to have a good approximation to the normal? Well, here we can see that just summing three of them, the approximation is more or less good. Well, here in blue, I have the shape of the normal distribution. We can find like a slight deviation from the normal, but that deviation is not too much. So just summing 4 or 5 uniform, the approximation to the normal would be good. And this is because the uniform is symmetric. So summing symmetric distributions, just summing a few of them, the approximation to the normal is good. Okay. In a future video, I will talk about the central limit theorem that explains, as I was saying, that the sum of uniform distribution can be approximated to the normal. And this is everything that I wanted to explain about the uniform distribution. Thank you very much for your attention.